Hi everyone, this is chapter 5, current and resistance. Before we are able to solve some problem related to the current and the resistance, we need to understand a few concepts. So let's start with the first concept we need to understand. What is the proper definition for the current? So the average current through, let's say, a conductor, a wire for example, is the amount of charge divided by the time period. This is the average current. The instantaneous current is I equal to the derivative of the charge divided by the derivative of the time. Now, most of the time, I will say 99% of the time, when I'm talking about the current, I'm talking about this definition over here, all right? We will solve many examples just to highlight the difference between these two. Okay, we also need to talk about the electric field inside a conductor. So charge are moving inside a conductor, but there's some resistance to this movement, and we will lose some amount of energy due to this resistance. And there's a link between the electric field inside the resistance and the drop in voltage inside that resistance. And we will see more example of this, but just for now, the link between the electric field and the voltage drop is the change in voltage is equal to minus the electric field multiplied by the length or the displacement among the conductor. So most of the time the conductor will be a wire, multiplied by cosine of the angle between these two vectors. Okay, so really it's minus the dot product of the electric field multiplied by the displacement vector. All right. Last concept we need to talk about. The way it works inside a conductor is a conductor has some free charge that can move, and these charge that can move can transfer the force, it can transfer the energy. And most of the time, if we are talking about a copper wire, for example, it is the electron. So if we want to know at what speed is the electron moving inside the wire, we are talking about something called the drift velocity. All right, so there's a link between the current inside a wire and the speed at which the electrons are moving. This link is the current is equal to N. Now this N is the amount of electron per meter cube. So at the amount of electron per volume in a given material. Now note this value is unique to all the materials. So it is set in stone for copper, silver, gold, and so on. Multiply by the cross-sectional area. Now the way we could think of the cross-sectional area is, let's say I got my marker over here and we got the electron moving to the right. Well, the cross-sectional area will be that side over here. If we were to chop the wire in two and look at the surface from the side, that's the cross-sectional area, 8 meter square. Multiply by the charge of the electron, E, multiply by the drift velocity, so at which velocity the electrons are moving. All right, so there's a few more concepts we need to consider before we can start solving some example. All right, so see you in the next video.